In this video, we're going to talk about matrices, introduce them, talk about what they are, some definitions, and do a couple of basic operations on them. So here's an interesting question, right? If I had this information about these two people, this is Joel and Amy. It's how many hours they worked in a week and how many overtime hours they worked in a week. So the total number of hours split up into normal hours and overtime hours. And I had their rate of pay for their normal hourly rate and then their overtime rate. How would I figure out what would be the natural way for me to figure out how much money each of them made? Well, I think I would take Joel's 40. So I take this 40 times this 8.5. So I say like 40 times 8.5. And then I would add that to the 8 times the 12.75. So 8 times the 12.75. And then that is going to equal whatever the sum is going to be Joel's total amount of money. Then I could take Amy's normal number of hours and multiply that by the normal hourly rate. So 40 times 8.5 again. But now there's a different amount of overtime, so 15 times 12.75. And I don't know what this answer is. These sums, I actually have it on this. I have it here. So this would end up being, if you get this sum, these sums are $442 for Joel and $531.25 for Amy. And it might not seem like it, but what we just did is something called matrix multiplication. And I hope that is at least a very brief, a very basic illustration of why matrix multiplication can be useful. You might not have thought that that's what was going on there, but in fact it was. Now, matrices are simply ways that we can arrange data, and it's data or it's pieces of information that were given to us about equations like we just saw, and it's used all the time. Matrices are used very often in computer science, specifically computer graphics, in business. They're doing analysis of markets and stuff. Sports for sports statistics for like advanced stats and like baseball. And of course we use them in math. And this is what a matrix looks like. So a matrix is kind of, it's like a rectangular arrangement of data. And this particular matrix has 4 rows. You can see that there are 4 rows and it has 3 columns. And so what we would say is that this is a 4 by 3 matrix. And you say 4 by 3, you say the number of rows and then the number of columns. And each of the things inside of a matrix are called elements. Sometimes, well, not sometimes, the standard way to kind of represent what element 4 here is A sub 1 comma 1, where that subscript there is the row number comma the column number. And sometimes it's just A11, and then that means that this next one would be A12 because it's in row 1, column 2. And so those are elements of a matrix. And there are some basics, some fairly simple arithmetic operations we can do with matrices. But first, it's good to have some practice defining the dimensions of matrices. So you can see this first one here. This is a 2 by 2 matrix. There are 2 rows, 2 columns. This would be a 3 by 2, 3 rows, 2 columns. This would be a 2 by 3, 2 rows, 3 columns. This would be a 3 by 4. This would be a 4 by 5. And so it's the number of rows by the number of columns. Now, this is one of the first operations that we learned for matrices is something called scalar multiplication. A scalar value, if you're familiar with vectors, scalar is just basically the magnitude part of a vector. It's one piece of information rather than two. They all fall in the tensor family, and that's too advanced for what we're talking about right now. But basically, scalar multiplication of matrices couldn't be more simple. You just multiply the number out in front of the matrix by each element. And that product this is the product of scalar multiplication. Addition and subtraction of matrices is also pretty simple, but it can only be performed with matrices of the same dimensions. So you can't have two different matrices of different dimensions and add them. It doesn't work because addition and subtraction is very straightforward. You take elements in the same location and just sum them, or you sum them if it's addition, or you find their difference if it's subtraction. And so you don't usually, you have this 5 plus 3. You simplify that to a symbol to a sum. You say it's 8, and you would just do that. It's just super straightforward math. We also have something called equivalency for matrices. That's if we have two matrices of the same dimensions and we set them equal to each other, that means that the corresponding elements are equal, right? So the top left, the A11 and the A11 are the same. They are equal if we have these are both 2 by 2 matrices. So I can say the statement that 5x is 15, 3 equals 10x minus 4, negative x squared equals negative 36, and so on. So this is an important thing to note for when we start talking, well, you may eventually start working with matrices. If you have equivalency, you can make these statements. Matrix multiplication, and we're not going to get too far into this. I'm just going to show you kind of the algorithm for how this works. But matrix multiplication is a pretty important thing. We're often tasked with multiplying matrices, and you can multiply two matrices together if they have all sorts of different dimensions. There are some things that are required in order to be able to multiply two matrices together, and we'll talk about that in a second. But here's kind of just the way that you do it. So you start with the first row and the first column, and you say, okay, it's A times G, and then we're going to add that to B times I, and then we're going to add that to C times K. And that whole sum, because we're in the top row, the left column, is going to go in the product matrix down here, the top row, top column. Okay, and then you would stay at the top row, go to the next column, you say A times H plus B times J plus C times L. That goes in top row, second column. Then you're done with the first row, so you're going to go down to the second row, and you'd have D times G plus E times I plus F times K. That goes here. Then you would have bottom row, second column, D times H plus E times J plus F times L, and that all goes right there. And so that's kind of the algorithm for multiplying matrices together. Now let's look at actually an example of one. So something to note is this is the same dimensions as the previous matrix, and we ended up the product was a 2 by 2 matrix. We'll talk about why that is in a second, but let's just do this here. So we're going to have 5 times 4 is 20, plus 3 times 3, which is 9, plus 4 times negative 2, which is negative 8. Okay, so that's going to be my top row, left column. Top row, left column. All right, now we're going to say in the top row and go to the right column. So we're at 5 times 5 is 25, plus 3 times 1, 3, plus 4 times 5, 20. Okay, then we're going to take, I should have done that in another color, oh well. Then we're going to take the 2 times the 4, and that's 8. Now the bottom row, left column, 6 times 3, that's 18, sorry. And then 7 times negative 2 is negative 14. And now bottom row, right column, so 2 and 5 is 10. 6 and 1 plus 6. 7 and 5 plus 35 is a 10. So now all we got to do is write what the sum is of these things. So 20 plus 9 plus negative 8, that's 21. Okay. We have 25 plus 3 plus 20, that's 48. We have 8 plus 18 minus 14, that is 12. And then 10 plus 6 plus 35 is 51. And so that right there, that is the product of those two matrices. So some rules for matrix multiplication is if you can only multiply two matrices together if the number of columns in the first matrix is the same as the number of rows in the second matrix. And matrix multiplication is not commutative. So where in normal math, right, if we have A times B, that's the same thing as B times A. But for matrices, this is not the case at all. if we had if we had a matrix that was a 2 by 3 matrix times a 3 by 5 matrix, we could totally do that. But if we instead said, all right, let's take the 3 by 5 matrix and multiply it by the 2 by 3 matrix, no can do. It doesn't work. Okay. So last step here is we're going to talk about how do you do this on a calculator. And so matrix multiplication and matrix operations in general on a calculator is very simple, and that's kind of where we're going with this. So what you do is you, on a graphing calculator, you go into matrix, which is second, and then this x to the negative first. And we can now enter in matrices by going to edit. And the first matrix that we were asked to enter here is a 2 by 2 matrix, so we're going to change the dimensions to 2 by 2. And then we're going to enter the data. So the way that we read a matrix off typically is from left to right, and we go one row, and then we're done reading left to right, we go down the next row. So it'd be -1, 6, 2, 5. So that is matrix A. Okay. Now, if we want to enter another matrix, you just go back to matrix mode and go back to B. Now we're going to enter in matrix B. This was a 2 by 5 matrix, 2 by 5. And the data is 5, 2, 3, 6, 2, 1, -2, -4, 4, -1. Okay, so that is matrix B now, right? So if we go back into our matrix menu, we see that A is a 2 by 2 matrix and B is a 2 by 5 matrix. And so let's do this operation. We wanted to know what was 2A plus 3B. So we go into our normal calculation space and we say 2, and now if we want to say, all right, we want matrix A to go in here, we go back into our matrix mode, and in the names menu, we just hit A. We say enter on A. So that is now saying 2 times matrix A plus 3 times matrix B. Okay, we know this shouldn't work, right? Because these are matrices of different dimensions, so it's not going to work, right? Dimension mismatch. So if we could do it, then it would work, but we can't, so it doesn't. All right, so now let's actually stop messing around. Let's say 3 times matrix A times matrix B. So we have scalar multiplication of matrix A, which is a 2 by 2, and then we're going to multiply that product by matrix B, which is a 2 by 5. Because those inner dimensions, the columns in matrix A and the rows in matrix B, because these are equal, right? That this 2 and this 2 are equal. That means we can do this multiplication. So let's type that in now. We wanted to have 3 times matrix A, so matrix A, and we're going to then multiply that by, and we don't have to have the multiplication sign there, but might as well, times matrix B, and it'll give us the product matrix right there. So this is the product. If we want to see what's in that last column, you just hit over to the right on your calculator, and you can find those values. So this isn't meant to be a comprehensive video about matrix multiplications whatsoever. We're talking about matrices in the context of systems of equations. And so the next video is kind of going to discuss how do you do that, how do you set up what's called an augmented matrix, and then what is the operation or the set of operations you perform on an augmented matrix to solve. An augmented matrix is just a matrix that represents a system of equations. So we'll get into that, and it's a kind of a frustrating process by hand, but the whole point of this is that if we can represent this information as a matrix, well, our calculators and computers are very capable of doing the algorithms that are related to matrices to solve these problems that would otherwise be enormously complicated and challenging to do by hand. If you want to know more about, I'll eventually make future videos about matrices, and we'll talk about things like determinants, inverse matrices, identity matrices, and maybe get into something called cross products. These are all kinds of things that are very fundamental to matrices and matrix math, but they're used more in fields like engineering, like cross products are used in engineering, when we talk about things like strain on structural members and stuff like that. But for now, like the basics that we're going to talk about for systems are don't really include these things. They can. There's ways to use determinants and inverse matrices to solve systems of equations too. But if we have this other way that we're going to talk about, that's not super important.